Alright, so now that you know how to create a frequency distribution, we're going to talk about the graphs that are made from a frequency distribution. So the first type of graph is called a frequency histogram. And a frequency histogram is a type of bar graph that represents the distribution of a data set. Now, to make a frequency histogram, there's a couple ways you can do it, and one of these ways uses something called a class boundary. And class boundaries are numbers that are used without separating, are numbers that separate classes without forming gaps. So for example, to give you an example of the class boundaries in our previous example, so we're going to be using this frequency histogram to make these graphs. If I want to talk about the class boundaries, what I'm going to do is I am going to find the numbers that go in between each of the classes and on the ends. So the numbers that go in between each of these classes are halfway. So basically we're just going to put a decimal point of 0.5 at the end. So what's right before 291? That's 290.5 because I just subtracted 0.5 from 291. What's right in between 318 and 319? Well, that's 318.5. What's right in between 346 and 347? It's 346.5 and so on. So 374.5, 402.5, 430.5, 458.5, 486.5, and 514.5. So these numbers are directly in between each of the classes. Okay, and these are called the class boundaries. So we're going to use these numbers to create the class boundaries in the histogram. Other characteristics of our histogram is that the horizontal scale is quantitative. So because we're dealing with a quantitative data set, your data is going to be quantitative. And the vertical scale measures the frequency and consecutive bars must touch. Now, if you use Google Sheets for this, you can't get the bars touching, and it actually really perturbs me. So I would advise using Excel. So I'll show you how to do and make histograms for and other types of graphs using Excel mostly. So don't use Google Sheets, use Excel because it has more features anyway, and it's more useful to you in my mind in the future if you know Microsoft Excel than Google Sheets. Okay. All right, so let's make this histogram. So we're going to title this female reaction times and all graphs need a title. If you don't have a title, the graph is useless because you don't know what you're talking about. And the vertical axis is frequency, and the horizontal axis is time in milliseconds. Now, frequency, if we look back at our data, our highest frequency for a class is 6 and our lowest is 1. So if I just count by ones, and I want to use up as much of the scale as I can, so I'm going to count by ones, but I'm going to do every other one. That way I'm using up a good amount of the scale. I could probably even do every third one if I wanted to, but you don't need to. And then the time, now this is where our class boundaries come into play. Now because I'm not starting at 0, I'm going to put a break in the axis. And I'm going to put tack marks at every other bar. Let's see, there's 8. 1, 2, 3, 4, 5, 6. So I think I need 2 more. Okay. And I'm going to put the class boundaries here. So my first class boundary was, if you go back, was 290.5 and 318.5, 346.5, 374.5, 402.5, 430.5, 458.5, 486.5, 514.5. And now we can create the bars. So my first class had a frequency of 5, and that was between 290.5 and 318.5. And I'll shade it so it's a little bit more apparent. My second class had a frequency of 4. And notice how the bars touch. Next one was 3. That goes back up to 5. Six. And 4, 1, 2. Okay, and that's a frequency distribution. Pretty simple, huh? Now, something that you should be aware of is that if you what you can do is you don't have to use the class boundaries. You can use what's called the class midpoints. So actually here, this is a relative frequency histogram. So I skipped the next graph and I went to relative frequency histogram. And a relative frequency histogram has the same shape and the same horizontal scale as the corresponding frequency histogram. So, you have your title. You should always have your title. The shape is the same. So I'm just going to write same as histogram. I don't think I need to make bars on a graph. I think you guys know how to do that. But instead of frequency, because it is a relative frequency histogram, we could do relative frequency. It's hard to write vertically. Always want to write the letters side by side. And then relative frequency histogram, you use the relative frequencies. So if I go back, I have to look again because I don't have it in front of me. The lowest relative frequency looks like 0.03 and the highest is 0.17. So if I count by, I don't know, 0.05. There you go. So your bars are going to be, like I said, the same heights and the same shape because everything else is the same. Also, you don't have to use class boundaries for the histogram. You can use the midpoints. Now, if you use the midpoints, I'll just show the first couple here. If you use the midpoints, make sure the tack mark goes underneath the middle of the bar. So the first midpoint, again, we're going to go back, is 304.5, 332.5, and 360.5. So 304.5 32, 360. Okay, so my first relative frequency goes up to 0.17. It's going to be a little shy of that guy. So notice that because I'm using the midpoints, and again, this is not just for a relative frequency histogram, this could be for a frequency histogram too, but just notice that the midpoints are underneath the center of the bar. Okay, so the next one would be 0.13. And the next one's 0.1. And of course you would continue the bars out, but again, I think you get the idea. I just wanted to show you that histograms can also use relative frequency, 1, and 2, that for either the frequency histogram or the relative frequency histogram, you can use class boundaries or class midpoints. Okay, there are two more graphs that I would like to show you that are related to this frequency distribution. So the next one is a frequency polygon. So as with all graphs, including the frequency polygon, we will have reaction times of women. And as with the frequency histogram, because it's a frequency polygon, you can also even have a relative frequency polygon, but we're going to count from 1 to 6. Okay. Now, the frequency polygon has to use the class midpoints. So, we're going to put a break in the axis. I'm going to put a tack mark down. Now, here's also the thing. The frequency polygon actually creates two, what I like to call pseudo classes. So, you're going to create a tack mark, but your first midpoint is actually going to be after that first tack mark. So, your first midpoint is 304.5, and then we're going to start counting. 332.5, 360.5, 388.5, 416.5, 444.5, 472.5, and 500.5. And if you can't read my handwriting below here, these are just the midpoint numbers that were from the frequency polygon. And you're going to create a tack mark after that. And I'll explain what you use this first and last tack mark for in a little bit. But before we get to that, all you do for frequency polygon is it's a line graph. So you put a point. For example, my first frequency is at 5. My second frequency is at 4, and we put points on these, and then we connect them with a line, like so. So let's do that. So 3, 5, 6, 4, 1, 2. Okay. And then at this point, we say, oh, I forgot my label, time in milliseconds. So don't ever label this class midpoints or class boundaries, by the way. Always give the labels context. So this is time in milliseconds. Okay, so we look at this, and then we say to ourselves, well, is this a polygon? And if you remember from geometry, polygons are enclosed figures. This is not enclosed. Well, that's what these are for. So, if I subtract, because remember, all these midpoints are 28 apart. If I add 28 every time, I'll get the next midpoint. Well, if I subtract 28, right? If I subtract 28, I will get 276.5. And if I add 28, I will get 528.5. And what this does is it creates a line that goes to the horizontal axis that encloses the figure. And now it is a polygon. And this helps you see the shape of the data better. So think about, when would I use a polygon and when would I want a histogram? Some people like the bar graph. Some people like to see how much the bar graph takes up. Okay? Some people like the polygon though. Some people like to see that you see the change from class to class better because they are lines. The slopes differ between each of the points. So these are all things you should consider when you're trying to display a data set. What points are you trying to get across the most? Because the subtle change, they're very similar graphs, right? A frequency polygon and a frequency histogram, very similar graphs. But using lines instead of bars emphasizes things more. So it just depends how you want to display the data. All right. And that's a frequency polygon. The last graph I want to talk about is my personal favorite, and that is the cumulative frequency graph. AKA the Ogive. Which is kind of fun, right? Okay, so I'm sure you're getting sick of this, but we're going to do it again. Female reaction times. And ogive displays cumulative frequency. So my highest cumulative frequency was 30 because that's the sample size. So I'm going to count by fives. 10, 15, 20, 25, 30. And once again, this is cumulative. Frequency. And cumulative frequency uses the class boundaries, and you have to use class boundaries. So we put a break in our axis. The first class boundary was 290.5. And next was 318.5, 346.5, 374.5, 402.5, 430.5, 458.5, 486.5, 514.5. And again, time in milliseconds. But now we're going to look at cumulative frequency. Now here's the thing. Cumulative frequency is how many data points are at that point and below it. So how much data do you have at the first class boundary or below it? Well, at 290.5, let's go back to our frequency distribution really quickly here. At 290.5, that's below the first data point. So there's nothing below 290.5. So we put a point at 0. Now we use the cumulative frequencies, which are 5, because that's basically everything in the first class, plus 4 is 9, 12, 17, 23, 27, 28, 30. It's a line graph. And you'll notice it's always going up. And that's because it should, right? It's cumulative frequency. So if I ever ask you, what's special about an ogive, and you say it's always compared to other graphs, well, first of all, it's always increasing. But if I ask you, what does this ogive tell you about a data set, and you say it's always increasing, that's not a characteristic of the data set, because it doesn't matter what the data set is. Cumulative frequency always increases. So what does an ogive tell you? Well, if you look at some parts of a ogive, like this part, especially here, or possibly compared to like this part here, this part is a greater increase than this part. And so you can tell where there's more of an increase and when there's more of a gradual increase from class to class, which is something that isn't as noticeable. You can still notice it from a histogram and a frequency polygon. But again, what do you want to emphasize the most when you display a graph, when you display your data? Okay, so these are all the graphs. Some parts I feel like I went a little quick on, but again, you can always go back to the book, start on page 40, read through some of the examples. Send me an email if you're struggling on some of the Math Excel problems for section 2.1. But at this point, you should be able to do the 2.1.